Hello student, in this video we are going to discuss about electrostatics. This is the part of electricity chapter which we have in 10th grade. So we are going to discuss about only those points which are there in 10th grade syllabus. CBSE will follow the CBSE pattern. So here's in this electrostatic, because electricity can be divided into two parts, current electricity and electrostatics. Electrostatics is that branch of electricity which deals with the charges which are stationary. So that's why this word electrostatic word will come. So static means stationary charge. So those physical phenomena which are related to a stationary charge, those are called electrostatic. Those comes under electrostatic. Here we have in 10th grade we have to discuss about only 2 points, electric potential and electric potential difference and its formula. So these are the 3 points which we have to discuss. First, electric potential, how to define this electric potential. Second point, how to define electric potential difference. So these 2 points, and third we have to define the formula. So these are the 3 topics which you have to learn in 10th grade. Rest all others like electric field, electric force, even capacitors, those things will come in 12th grade. So here we have to discuss only about these 2 points, electric potential and electric potential difference. So now let us start what is the concept behind this electric potential. So suppose look, this we cannot explain potential or potential difference without explaining the electric field and electric force. So little background I'll give. So suppose there is one charge. Suppose one charge is placed here, positive charge. And whenever we have one charge, in the surrounding area there is electric field. And if you place another charge, this field means how we define field, because if you place another charge in this field, then it will feel a force. Suppose one positive charge, then it will feel a repulsion. And if you take any another charge, Q here, minus Q, so then it will feel a attraction. So that is how we define electric field. So field is the area in which if you place another charge, it will feel a force. So electric field is always developed because of this charge, positive charge. In case of positive charge, this is the convention that electric fields are coming out of it. So now look, this is the electric field, concept of electric field. Now suppose we have one test charge. Test charge can be anything. So suppose this one test charge is plus Q, we are considering this as test charge. If you bring this charge to a particular point in an electric field, so suppose this is the electric field. In this electric field, we have to bring this test charge to this point P. Now we have to do work against the repulsion, because just now we discussed that there will be one repulsive force because of this electric field. There will be a repulsive force on this test charge, and we have to do work against this repulsive force. So we have to bring this charge to a particular point P in an electric field. So that's why if we have to do some work against the electric field. Whatever work we do, that will be stored in that charge as a potential energy. So this is how we define the electric potential. So electric potential is, and this is always, potential word always comes for conservative forces. So electric force is conservative force. So now we can define the electric potential. How? So this is the definition, that electric potential, and one more thing, electric potential is always about one point. Suppose Vp we want to find out. P is the point in an electric field, P here. And potential difference is always about 2 points, suppose between A and B inside the electric field. But these points are always inside the electric field. So here, now suppose you bring a unit charge. So first unit charge, suppose we'll take one test charge. Suppose this is the test charge Q, plus Q. Now we have to bring this to particular point P here. So we have to bring this charge to point P. So we have to do work against the repulsive force. That work is known as electric potential of this point P. So this is how we define. If you bring a unit charge from infinity to a particular point P in an electric field, whatever work you do, that is known as electric potential of that point. So now we can define, now this is the specific formula. So Vp will be written as work done in bringing a unit charge from infinity to particular point P divided by the test charge, because per unit charge we have to consider, means 1 coulomb. So this is one formula. This is about electric potential, and potential difference is similar. The only difference is that in case of potential difference we have to take 2 points inside the electric field. So suppose here these are the electric field. So here these are the electric field. Inside the electric field we have to take 2 points A and B. Suppose this is A and B. And if you take a unit positive charge here, suppose we have one plus Q test charge. If you are taking any plus Q charge, then it is a test charge, not a unit charge. Unit charge means 1 coulomb. So here suppose one test charge we have plus Q. Now you have to bring it to the point B. For that we have to do a work again, because there will, whenever we have a charge inside the electric field, there will be force, and whenever there is force we have, and you are moving in an object, then we have to do some work. So we are doing some work against this force which is developed by the electric charges. So this, to bring the now we can define electric potential difference also. How to define now? The same formula, W by Q, but here the work done in bringing a unit charge from point A to B. So this is the definition. This is how we defined it now, potential difference. So potential difference is always about 2 points, and here it is work done in bringing a unit charge from point A to B. Unit charge means we have to divide by Q. So this is these are the two different. So this is the only difference between potential and potential difference. First difference, it is always about 1 point. Second difference, it's always about 2 points, and these 2 points are inside the electric field, and when these are the charges. So that's why even if you take unit charge, it will feel a force. If you do some work against that force work will be stored in that charge. So that's why its potential energy will increase. So that's why we have given the name potential. So this is the difference. And similarity, both are potential difference, potential and potential difference, but one is about 1 point, another is about 2 points. And here work done from infinity to a particular point P, and here work done from point A to work done in bringing a unit charge from point A to point B. So these are the 3 things which we have to discuss in 10th grade: electric potential difference and its formula. Little bit changes are there. Here infinity to point P, and here point A to B. So this is all about this electrostatic topic which we have in 10th grade, which is very a small part, but there is chance that in from electricity chapter, one question you can expect from this these two topics, electric potential and potential difference, in board exam. So that's why this is also important. So in next video we'll discuss something about something more about the electricity chapter. So stay tuned and see you in the next video. Thank you.